what I've learned as a high school teacher is that sometimes it's necessary to rationalize, sometimes it's not. So I think on your guys's, well, I don't know. I feel like sometimes for multiple choice answers, they will simplify the radical and sometimes they won't. So it's a good skill for you to have, but if you don't do it every time, it's not necessarily an issue. When you get into calculus, sometimes they will leave the radical on the bottom, sometimes they won't. It just kind of depends on the problem and how easy or difficult it is. So we're going to practice this not because you have to do it 100% of the time to get it right, but because sometimes you do to find your multiple choice answer. Does that make sense? Okay. So when they say rationalize, what they mean is make it so the problem is equivalent, but no longer has a square root on the bottom. That's what that means. So for number 1, to rationalize that, we're going to multiply by the square root of 5 over the square root of 5. And the reason that you can do that is because when you multiply by a number over itself, you're multiplying by 1. So I'm changing what the fraction looks like, but I'm not changing the decimal that it represents. It's still going to represent the exact same thing. So 1 times the square root of 5 is just square root of 5. On the bottom, square root 5 is the square root of 25, which is 5. So we've got root 5 over 5. It is now rationalized. Now, if you type this into your calculator just for comparison's sake to make sure you understand what you're doing, 1 divided by square root 5 is that decimal. Square root 5 divided by 5 is the exact same decimal. So the number's the same. I'm not changing it. It just looks a little bit different. It's like writing your name in print and writing your name in cursive. It's still your name. Make sense? Okay. Let's try another one, shall we? Let's do number 5 with all the 5s in it. Hope you're not scared of 5s. That would be a bad omen. Good joke, Ms. Rice. I know, right? Okay, so I'm going to multiply it by root 5 over root 5. And so on the top, what do I have? Yeah, 5 times root 5. And what do I have on the bottom? 5. And then what happens? The 5s cancel, and you are left with just plain old square root 5. Well, look how fun that was. Okay, while you guys continue working on the warm-up, I'm going to come around and pick up your assignments. There's no answer key in the back because I didn't make one. You're welcome. All right, go ahead and get working. Okay, any that we need to talk about?
That's a 3. Yeah. Oh, okay. That looks like an 8.
It's a 3.
It looks like an 8.
I'm very talented at drawing 3s, so sometimes I make them look like 8s. All right, so we good? We good? All right, let's move on to something completely different. Go ahead and get these notes in front of you. Yep. Actually, we're going to start with the unit circle first. Go ahead and get this in front of you. All right. I have an extra credit opportunity for you. This is what it is. You can come in for an optional quiz. This is an extra credit quiz. And during that quiz, I will hand you a blank unit circle and you will fill it out. That is the quiz. It's a memorization quiz. You memorize it, you come in, you fill it out, you get extra credit. You can do this at lots of times. It just has to be done before the test. And the quiz will take you approximately 1 to 5 minutes. Some people can do it real fast. Yes?
What will it count as? Like a regular quiz?
It'll be a quiz score.
What if we fail?
Then it will just be nothing.
Oh,
Yeah, it doesn't count against you. Well, I mean, if you get 50% of it right, then you'll get a 50%. And then you'll be like, Ms. Rice, please don't put that in as a quiz. And I'll be like, okay. All right. So let's go ahead and fill in the degrees we know. I know this is 0 degrees. What else do I know? I know this up here is 90. What about this one over here?
180.
180.
Wait, how are you feeling? Oh, like on
The degrees that we know, yeah. We know that this one down here is 270. Ooh, and we know if we get back to the circle, this is 360. Okay. What about this one right here?
Probably 45.
Probably 45. Okay. All right, so that's right in the middle of 0 and 90. What's right in the middle of 90 and 180?
135.
Interesting, okay. What's in the middle of 180 and 270?
225.
225. But how could you find it if Daryl was not right there? Add them together, divide by 2. Okay, what about the middle of these ones?
350.
315. Okay, now if I look at this right here, so here's a 90-degree angle, and then I look at this. How many pieces is it divided into? 3. Okay, so what are these two angles? 30 and 60. Okay. I just showed you guys that it was divided into 3. And so then we said, oh, 30, 60, 90. And then, okay. And then, the 135 is in the middle, so we're ignoring that right now. But we know the other ones are going to go by 30s. So 90, 120, 150, 180. What comes next? 210, 240, 270, 300, 330, and then a 360. Okay, so there is all of our degree measures. Next, we have fractions. Who's excited? I'm excited for some fractions. I think the fractions are better if we have colors, though. So go ahead and go grab some colors. Maybe like, you don't have to do colors. I don't know. Grab like 3 or 4 colors.
Grab all of the remaining colors.
Don't grab any colors for him. He doesn't like colors.
Yeah, don't grab any for me. All for yourself.
Probably not. Maybe, maybe, no. No. So here's what I need from you. I need you to take a color and go across the middle. Okay, so we know that this is 0 radians, and what's this over here? It's 1 pi. That's pi. Okay. Same color.
I got it.
Okay, so this is 1 whole, and we just cut it in half, so what goes right here? 1 half. Okay.
Oh no, I did one. Oh, I got away from 2.
That's okay, that's okay. We're going to do that next. Whew. Whew. Okay, so this is 0, 1 half, 2 halves, 3 halves, 3 pi over 2, and then 4 halves, but I'm not going to put 4 over 2. I'm just going to do 2 pi. Okay. Now I'm going to switch colors. Okay. So what you will learn is that the color you just did, that color gets used every time we count. Okay? So mine's purple. I'm going to count purple every single time. Okay? All right. You're going to get it once we start doing it. Okay? This was purple. Okay. Now I've got a new color. You'll get it in a second.
Just follow what you did.
Just follow what I'm doing.
Wait, I missed what you did. I screwed it up.
I'm adding green.
Oh, so I'm adding
You add whatever color you want. Okay.
You're putting another S through the
It's a light green. It's very okay. So if this was 0 and 1/2, then what's in the middle? 1/4. Okay. Now we are going to count together again, and we are going to count the purple with it. Okay. The purple always gets counted. You'll see what I mean in a second. Okay. We've got 1/4, 2/4. Okay. 3/4. Yep. And then we've got 4/4, which matches with 1. 5/4. And then we've got 6/4, which matches with 3/2. And then 7/4. And then we have 8/4 that matches with 2. Okay? So we count the purple every time, but it's already written down. Okay? 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. We're going to do it in 6 next. Okay? We're going to change colors again. Yeah, I'm literally going to hand you this exact same sheet again. No cheat sheet, though. Yeah. All right, so if we look at this, we can see this is 1, 2, 3, 4, 5, 6. You guys see that? Okay, so we are going to count by 6 this time, and we include the purple. Okay, so we've got 1/6.
I said non-use a light, but pink and
They're confusing. We've got a 1/6, and then what comes next? 2/6, but I'm not going to write that down. I'm going to write down 1/3 because that simplifies. So 1/6, 2/6, 3/6. That matches what we already have.
Can we write 4/6? What was the one not simplified?
It's 2/6, but we write 1/3.
Wait, if we put 2/6 on the quiz, would we get it wrong?
Yes.
Wait, what?
Simplify. Okay. Because it was divided into 6, not 5. Okay. 1/6, 2/6, 3/6, 4/6, but we're not going to write that. Instead of, we're going to write 2/3. 2/3. 1/6, 2/6, 3/6, 4/6, 5/6, 6/6. Okay? Or 1. 7/6. 8/6, but we don't write 8/6. 4/3. 9/6.
Wait, you're going way too fast. I'm lost.
The good news about this is you can Google unit circle and you have about 1 in a million pictures to choose from. It's very common. 9/6, what about over here?
5/3.
10/6, which is 5/3. And then we have 11/6. And then 12/6. And we're done. So we're going to learn those in a second. So when we do the degree measures, I think the degree measures are the easiest, but I think the radians, if we are comfortable with fractions, the radians are not so bad. We just got to count our fractions. Okay? Whew. We good with that? All right. Go ahead and put your unit circle off to the side and put this in front of you. That's what we're going to get right now. We're going to see how we get those. Whew. Now, That would be cool, though. All right, so here's what we got. You will need your markers. You probably won't need your markers, but go ahead and leave them on your desk. Just leave them there. All right. So this is a special right triangle. It's a 45, 45, 90. So we've got 45, 45, 90. This is labeled as A, and this is labeled as A. It's an isosceles triangle, which means that if the two base angles are the same, then the legs are the same, or the sides are the same. Does anyone remember what the third side is? Nope. It's got a special little trick to it. No. It's A times the square root of 2. Square root of 3, hang on to that, though, because we're going to use that in a second. It's A times the square root of 2. Okay. So this picture of a circle right here is called a unit circle. We make something a unit circle when its radius is a length of 1. 1 as in 1 unit. Okay? This is a coordinate on the circle, x, comma, y. X coordinate, y coordinate. Okay? So if I take this and I drop a line straight down to form a right triangle, then that means that this length of the triangle is an x because we go right x. And then this length of the triangle is a y because we go up y. Okay? You can use different colors if you want. Nope. All right. This right here is a 30-degree angle. So that means this one's 60. There's our 90. Okay, so that's not the shortcut we just used, so we're going to skip that one for a second. Okay, let's go to this one. All right, we've got a unit circle again. We got a radius of 1. We've got this. This is an x coordinate and a y coordinate. We're going to take our line. We're going to drop it straight down. That means we've got a triangle. And in our triangle, we have a side of x and a side of y. This is a 90-degree angle. This is 60 degrees. So the other one's 30. Okay. I made it the paper so that it would be 60. Yeah, it's 60.
Wait,
okay.
So the one that's on top of well, if you're looking at it this way, the one that's on top is always 90 or 60. Sorry.
Yeah.
Okay, and this one's always 30.
Yeah.
In this situation.
She's pointing to something different than what you're thinking of. All right, let's look at the back. Now this one, this is the one we wanted originally. We have a unit circle again. Okay, we got a radius length of 1. We've got an x and a y. It's on the back. It's on the back. All right. Okay, so we have a 45, 45, 90 triangle. And the 1 is the radius of the circle, which is also the hypotenuse of the triangle. And if you look at the front of the page, the 1 equals the a square root 2 side. Would we agree with that? Okay. So I'm going to say 1 equals a square root 2. And now I need to solve for a. So how do I get the a all by itself? Okay, so 1 over square root 2 equals a, but we don't like it when answers are written like that. We got to fix it. Miss Rice, is this why you had us do the warm-up? Why, yes. Yes, it is. Yes, it is. I planned ahead. All right, thank you. Yes, round of applause. Round of applause. Thank you. No, stop. No, stop. No. All right, so what do I need to do to fix this? Root 2 over root 2, and so a equals root 2 over 2. Okay. So this was the a square root 2 side. This was the a side. This was the a side. So x equals root 2 over 2, and y equals root 2 over 2. And that means that the point is root 2 over 2, root 2 over 2. Now let's get our unit circle back out. Ta-da!
Wait, go back. Can we take a couple seconds?
Hold up. It's processing out.
Okay.
All right. So we get our unit circles back out.
This one right here.
So we say 45 degrees. That's the 45 degrees from the 45-degree triangle. And we go here and we say our x is root 2 over 2, and our y is root 2 over 2. Okay. Now, this is the first quadrant. And in the first quadrant, your x-coordinate is positive and your y-coordinate is positive. Right? You guys are very complainy today. All right. In the second quadrant, the x-coordinate is negative and the y-coordinate is positive. So I'm going to use the same numbers because green is green, right? It's the same. But I'm going to use a negative for the x-coordinate and a positive for the y-coordinate. So it's the same, but just a smidge different. Why are you confused?
Because how did we get square root 2 over 2?
We got it from this.
But why is that? How did that slide there?
Because it says 45. It's 45. It's a length of 1. There's the x and y coordinate. It's 45. It says unit circle. So it's a length of 1. All right. Shh. Hey, guys. I think we've realized that today our minds are going to be blown just a little bit. We're going to have a hard time grasping some of it. So I need you to not goof off when other people are asking questions. Okay. All right. We're going down. Yes? You know the next one? So quadrant 3 is negative, negative. And so negative, negative. Yeah, it's like a graph. Yeah, these are x and y coordinates, just like a coordinate plane. Okay. And then the fourth quadrant, positive, negative. So root 2 over 2, negative root 2 over 2. Whew. Yeah. But do you guys see how like everything has like a mathematical reason for where it is? Okay. Let's go back to the other sheet. Okay, we're going to flip to the front. All right. Now, this is the 30-degree angle. This is the 60-degree angle. This side is a length of A. This is a length of 2A. And Michaela, what's the other one? Yeah. Thank you, Michaela. Marvelous. All right. Oh, look at this. This matches up perfectly. It's like I planned it. So the 1 is the 2A side. All right, so I'm going to say 1 equals 2A. And now I'm going to solve for A. That's getting real distracting.
This is going this way. And I think I'm going to enjoy it.
It was me. It was me. All right. So. Yeah. All right. So we have, this is 1. What's the y going to be? It's going to be 1/2. Okay, so we got this one. That's just 1/2. And then the other one's going to be 1/2 times root 3. Okay, so 1/2 times root 3 is root 3 over 2. Okay, so at 30 degrees, our x-coordinate is root 3 over 2, and our y-coordinate is 1/2. Okay, so now we get the unit circle back out. Okay. So we have root 3 over 2 for x, 1 over 2 for y.
So, Miss Grace, is it called a unit circle because this is equal to 1?
Mm-hmm.
Yeah.
And then this one over here is negative root 3 over 2, 1 over 2. And then this one right here is negative root 3 over 2, negative 1 over 2.
Oh, shoot. I wrote that wrong. Oh, I think I know. Shoot.
And then this one is so when I was in high school, did I tell you guys about the award I won in high school? Yes. For most joy in mathematic discovery. On the day we went over the unit circle, I was like, oh my gosh, there are connections there. There were like lights shining. There was like, it was crazy. All right, let's look at the next one. Okay, so this is very similar because we have just the rotated version of this one. Okay, so the side that's across from the 30-degree angle, remember that was the 1/2 side, that was the shortest side, okay? So the side across from the 30-degree angle, all right, is the 1/2. And the side that was across from the 60-degree angle was the root 3 over 2. So it's the exact same triangle. It's just been like reversed, like flipped kind of. Okay. The question everyone is dying to know is, Miss Rice, do I have to do this again? No. No, you do not. The only part you have to memorize is the unit circle, and that's only if you choose to. When you get to pre-cal, you need to memorize it that year. When you get to calculus, we start using the unit circle, but we don't have a picture of it anymore. It's just in your brain, okay? So we start you off where you can see where it came from. We practice using it in Math 3, but by the time we get to pre-cal, we memorize, okay? All right. Whew. All right, so let's go ahead and put this one in. We've got 1 over 2, root 3 over 2. Okay, what's this one? Negative 1 over 2. Okay. Okay. Now, we have some coordinates missing. These were the easiest ones, though. So somebody tell me again, what's the radius length? 1. Okay. So from 0, 0, right here in the center, we have 0, 0, and we go to the right 1. So this point is 1, 0. So we start in the middle at 0, 0. And we go to the right a length of 1. We get 1, 0. Okay. So start at 0, 0. We go up 1. 0, 1. Start at 0. Go left 1. Start at 0. Go down 1. All right. Whew.
That one's supposed to be a negative root what the pink line in the fourth quadrant. Other, yeah, that's a negative.
Positive root 3 over 2, negative 1/2.
The other thing.
Positive 1/2, negative root 3 over 2. Now, if you are not sure that you wrote all these down correctly, all you have to do is Google unit circle and compare it with one of the ones online, okay? These are very easy to track down. All right, so let's go back to our other notes. We're going to notice a few more things, okay? So, Slippy? Okay. There's actually more things to see. All right, now in the pictures we just drew, go ahead and draw this right triangle like this. Thank you. All right, so this is what we were drawing each time, right? And the angle that we were talking about was right here, so I'm going to put a theta right there. Theta, with a TH. Okay. And we know that sine is opposite over hypotenuse. Okay. Let's go ahead and in this picture, let's label the names. Let's label the names of the sides. Hypotenuse, y is opposite. Okay. All right, so sine is opposite over hypotenuse, which is y over 1, and anytime you divide something by 1, you don't even have to write it, you just say y. Okay.
X over 1.
You're spoiling the answers, lady.
We'll let Jamie answer this one.
Any guess? I think you can figure it out. Y is the same thing as sine. Okay. Yeah, this is something that it's the longer you get into math, the more you go like, ooh, that makes sense. And then like, ooh, okay. And then later it's like, oh my gosh. Like it's like it goes, you know? So if your brain is exploding a little bit today, it's fine. Okay. So opposite over hypotenuse, right? Y over 1. That means that sine of an angle is just the y coordinate. That's what that means, okay? Cos is adjacent over hypotenuse, which is x over 1. That means that cos is just the x coordinate. So if I wanted to know what cos of 30 was, and I didn't have a calculator with me, I could grab my unit circle and look at the x coordinate at 30 degrees. That's what that means, okay? And then here, tan is opposite over adjacent, which is y divided by x, or sine over cos. Okay, so in the unit circle, the x coordinate is cos of the angle, and the y coordinate is sine of the angle. And we don't want to forget that, so we're going to write that on our unit circle, okay? I would say that the unit circle is like your cheat sheet to start with, and then whatever else you need on your cheat sheet, I would write on the back. But this should be like your cheat sheet to start. Okay. So now I'm going to go ahead at the top. I'm going to write cos theta, comma, sine theta, so that I know that my x corresponds to my cos value, and my y corresponds to my sine value. And then I'm going to go ahead and say that tan theta is y divided by x. I just want to have that on my sheet. It's going to make my life easier. No, you don't have to write it. I mean, I don't know. All right. So here's what we're going to do. We're going to grab a blank sheet of paper. You need a blank sheet of paper.
Like a line or like?
It can be lined. If you want to put your marker back, now is a great time to do that.
Oh, the section is fine. What is it? No. I have to
Put them up. Yeah. Okay. So first I'm going to say cos of 30 degrees equals. Okay. Cos of 30 degrees equals. Okay. So I'm going to grab my unit circle. I'm going to find 30 degrees, and I'm going to look at the x coordinate. So cos 30 degrees, I'm going to find 30 degrees. I'm going to look at the x coordinate because this is cos, and I'm just going to write it down. So what is my answer? Root 3 over 2. Boom, done. It's crazy. Sine of 3 pi fourths. Whew, okay. I'm going to find 3 pi fourths. And then because this is sine, I'm going to look at the y coordinate. Mason, I'm about to chuck that phone across the room. So my y coordinate is root 2 over 2. We get it? So 3 pi fourths. It was sine, so I look at my y coordinate. Root 2 over 2. Okay? Tan 180 degrees. So we got to find 180 degrees, and then we have to do y divided by x. Wait, y divided by x. 0 divided by negative 1, which is 0. Not negative 0, just 0.
What did you have genius math right there? What happens if you have tan of 90 degrees or 70?
Tan 90 degrees.
Nothing happens.
One divided by 0 doesn't work. It's undefined. You will see once we start graphing. But I'm trying not to overwhelm you today. Okay. Too late. Yes. The y over x is because we know tan is y over x. Yeah. All right. Cos of 5 pi thirds. Cos of 5 pi thirds. Cos 5 pi thirds. You would go to 5 pi thirds and you would look at the x coordinate because it's a cos and it's 1/2. Because cos says only the x coordinate. That's what we did. Why is it 1/2 is all the stuff we just did? It's a triangle. All right. Sine 225. Sine 225. Sine 225. Nah. Negative root 2 over 2. All right. Tan 45 degrees. All right, tan 45 degrees. It's 1. It's 1. Okay, so if we look at 45 degrees, we have y divided by x. So we have root 2 over 2 divided by root 2 over 2. And thank goodness it's 1. Whew. Okay. Oh, yeah. Like the one we're about to do. All right, tan 60 degrees. Tan 60 degrees.
Ow. Head owl. Head owl. Oh, wait. Don't tell us the answer. I want to try to figure it out.
Yeah, I want to do this together. Anybody says
Yeah. If you guys have noticed, this is a completely calculator inactive activity. Have you guys noticed that?
Yeah.
This like coming onto a test day, this would be a no calculator portion. Okay. All right, Michaela, talk me through it. Yes.
Okay, because it's like when you divide a fraction, you flip the second one.
Yeah. Okay. So we have y divided by x, right? And then if we're showing our work, we say keep it, change it, flip it. So keep the root 3 over 1, change it to a multiplication problem, flip. Oh, that's a 2. That's a 2, sorry. Root 3 over 2, keep it, change it, flip it. And then what happens with the 2's? They cancel out. And we get root 3 over 1, which is root 3. Okay, the other thing that students like to do is they go, oh, those cancel.
That's literally exactly what I
Yeah. All right. You can do that. Okay. All right, we are on a roll here. Let's try tan 30.
No.
I like you guys defending my honor. No, this is Miss Rice's class. We learn all the time. We never stop learning.
We're not necessarily.
We never stop learning. I never stop learning.
It's in subscribing.
It's what? No.
Oh, I keep doing this wrong. I keep putting.
Okay, so y divided by x, we know we can get rid of the 2's, right? But is 1 over root 3 even okay to write? I gotta fix it.
I know. So square root 3 over 3 is like.
Woo!
Summer blowout. Is that what
Miss Rice, can we be done? No, let's do some more examples. Start a brand new sheet.
I'm down with doing examples for the rest of the class. I am not down for doing this.
All right. Sine of pi. It is 0. Huh. Well, sassy.
Love you, baby.
All right. Cos of 0. It's 1. Can anyone tell me if this angle is in radians or degrees? It's not both. It's not both. It's radians because it doesn't have a bubble.
Oh, yeah.
All right, example. Tan. Is tan your new favorite? That's what always happens. Tan 5 pi fourths.
Wow.
Tan 5 pi fourths.
Oh, wait. Would this be when it's like 1 again?
And why is it 1? Yeah, negative root 2 over 2 divided by negative root 2 over 2. Yeah, it's just 1. Negatives cancel. All that cancels. Okay. But what about tan 300? Or tan 300? 300. Ooh, Ms. Rice is so cool, and I love this math.
Wait, did somebody not shout out the answer for the
Right.
Wait a second.
Wait, no, I don't. I don't understand. Wait.
Oh my god, I got it. You can shout it out.
Oh my goodness.
We're doing y divided by x.
Oh. Wait, stop hacking.
I got the answer. I got the answer.
And so what do you get? Negative root 3. Woohoo! All right. Tan 3 pi over 2. Tan 3 pi over 2.
That just equals.
I know.
I'm just so slow at reading that this text is
You could Jenny, you could, like, I understand how to do it, it's just, I'm so slow.
honestly, that's probably.
Equals?
Come on.
It is undefined.
No.
Root 3 over 2 is down here. Yes. All right. I think we have enough notes.
Yeah.